Hi, this is Rich with Inside HPC. Welcome to the Rich Report. We're here for a series of conversations from the HPC User Forum. Today, my guest is Doug Kothe from the Exascale Computing Project. Doug, welcome to the show today.
Thanks, Rich. Great to be here.
Well, it's great to see you through the social distancing. So we see each other 2, 3 times a year, it seems like, for these HPC User Forums and the various conferences. But we want to get some more about the background from the steering committee. So let's start there. How did you get into HPC?
Okay. First of all, here is in the basement of my Knoxville home. You know, we are all working at home these days, so it's good to be able to connect with you, Rich, and the HPC community. So for me, it was mid 1980s. I was doing my PhD research at Purdue University in inertial confinement fusion. So I guess I would call myself a trained physicist, and it was really fortuitous. But my professor, Chan Choi, was a consultant at Los Alamos at the time, Los Alamos National Lab, and took me out there in the summer of 1984, where I was exposed to computing, and I sat in an inertial fusion and plasma theory group, and was mentored by Jerry Brackville in particular, but a number of staff there that exposed me to their plasma physics codes and hydrodynamics codes. And at that time, I was logging in remotely on a 300 baud modem um, to MFECC, the Magnetic Fusion Energy Computer Center, which is now NERSC. And so my first exposure was running some Fortran, well, they're probably Fortran 66 codes in Fusion, and just got hooked on being able to will the computer to do interesting science and physics. And so I was hooked in from the summer of 1984 that way, and didn't plan it, but I'm sure glad it happened.
Okay. So what have you been up to since, at least before you got into this role?
Oh boy. So I've been at Oak Ridge National Lab now for almost 15 years. And before that, Los Alamos National Lab, as I mentioned, for 20 years, and Lawrence Livermore for one. So I guess I'm doing the DOE lab tour these days. That said, at Oak Ridge National Lab, I've had 3 jobs. And one of the nice things about national labs is they're so full of diverse people and diverse sets of disciplines that you find yourself getting interested in new problems and challenged by new things. And you don't have to be a careerist and plan your next move. Interesting opportunities just happen. So for me, before Exascale Computing Project, I was fortunate enough to lead the first DOE Energy Innovation Hub, known as CASTLE, the Consortium for Advanced Simulation of Light Water Reactors. We built a virtual reactor that I think, by all measures, was very successful, known as VERA, the Virtual Environment for Reactor Applications. So I did that from 2010 to 2015. Since 2015, actually April Fool's Day 2015, I've been involved in trying to initially help start up the Exascale Computing Project with Paul Messina, and running it the last 2.5 years. I first came to Oak Ridge in 2006. Thomas Zachariah and Jeff Nichols recruited me. I want to say I was the 10th or 11th new hire into the Oak Ridge Leadership Computing Facility. So they had won the Leadership Computing Facility Award jointly with Argonne, I think, when I say they, Oak Ridge and Argonne, in late 2004. And so they recruited me about a year later to come into the OLCF, Oak Ridge Leadership Computing Facility, as their first director of science. And that was a fantastic job that they let me define as my own. And I did that job for 2006 through 2010. So I'm on my third job right now, Rich, and really enjoying it here at Oak Ridge.
That's terrific. Well, Doug, you've certainly seen a lot of changes in computing, but what are the major changes that you've seen in HPC?
Oh man, that's a tough one because we've seen so many changes. Every change seems disruptive and scary, but in retrospect, at least in my experience, they have not been as much so. And I think it's because as a community, we're fast moving, we're agile, we're always learning. I think we're really on the cutting edge of our craft. And I'm going to say this not because I've been in this community my whole career. I kind of have and kind of haven't, meaning I've done stints in nuclear energy and with fusion and other areas. And I think other domain sciences don't move as quickly as high performance computing. So every change seems scary and disruptive. And in retrospect, I think we forge our way through. But, I can remember working on the connection machine and just really loving the SIMD approach and programming in connection machine Fortran CMS or Fortran 90, really feeling like PVM and MPI was going to be super disruptive and scary. And is this really going to work? And, over a period of a few months, we ported our code from CMF, Connection Machine Fortran, and I still have a copy of that code, by the way, to MPI. And it was surprisingly not easy, but we pulled it off, and it was fun, and it worked. And, we look back going, wow, this actually wasn't as bad as we thought. Well, here we are now, especially in ECP, we're worried about accelerators. Okay, we've got different types of GPUs. And frankly, at Oak Ridge, I was part of standing up the first large system with GPUs. Although I would argue that the cell-based system, certainly Roadrunner at Los Alamos, was the same situation. Sure enough, I think we found that it was disruptive and scary, but we pulled it off. And we're seeing the same thing in ECP, Rich. We're seeing we're figuring things out and knocking down barriers, and exciting things are happening to make accelerators, really more demystified and accessible. Everything from interesting abstraction layers that creative people are working on, like Raja and Cocos, to pushing the standards of OpenMP, to moving toward what I would hope to be a more unified programming model for accelerators. And so, this has been a big change, but it's hard for me, Rich, to, being an old person here, to not look back and say, every one of these things was somewhat disruptive. But I think the talent of the community and the agility of the community really is a testament to the fact that we collectively pull it off. So.
Well, good. Well, you've kind of touched on this, but where do you think HPC is headed? Is it, heterogeneous, accelerated computing? And you're at the forefront of this with your team.
Certainly, I do think that's the case, Rich. And I think that we would have failed in ECP if we develop a one-off boutique set of codes and programming models. Now, and we're not really forcing, frankly, nor should we, one programming model. But I do think what we're seeing is we are collectively figuring out how to adapt to and program on very heterogeneous architectures. And I think they are here to stay, certainly in my career. But I think frankly, I think decades. If you sit back and go, an accelerator could be if you view an accelerator as, and I do view it this way, as hardware that is tuned to accelerate certain operations. Let's just take the Volta V100 really does make, with this matrix multiply, accumulate 4x4 tensor screen. So that's a very specific hardware acceleration of a specific algorithm. So by that definition, I think they're here to stay. We're going to see accelerators that are tuned to certain operations. And certainly AI machine learning is driving that market. I mean, that sort of roadmap. But I think we're going to see all kinds of interesting possibilities that are based on, let's call them computational motifs or domain-based languages, and even ASICs. I mean, certainly with neuromorphic and quantum, one can step back and say, this is an accelerator. And I think what we need to do in ECP is develop the underpinning and the groundwork to be able to exploit those accelerators in a way that is not too, back to your term, disruptive to what we've done already to our applications. The proof will be in the pudding, but I feel like we're on a good path.
Yeah. Well, are there any HPC trends that have you particularly excited or concerned?
Mostly excited, Rich, but let me just be a little retrospective and then try to look forward a little bit. Relative to 10 or 15 years ago, Rich, the development environment, the IDE, the development environment for computing is really very mature. I'm really continually amazed at the tools we have at our disposal to do configuration management, to do issue tracking, to do continuous integration and testing. I'm just really fortunate that we don't have to essentially roll our own a lot like we used to. Roll our own testing system, our build system. These things are black holes for people's time and talent and funding, frankly. Right now, we're all trying to figure out, and then maybe we won't, but what's the best container? What's the best virtualization? And well, while we're not thrashing around, there's just this tremendous technology. I think I am concerned that the community won't move into a direction that is sort of unified with regard to containerization. And here's where the HPC community needs to sit more closely with the cloud community and say we're one community. We need to learn from each other. And I think the cloud community, is really, frankly, ahead of the more traditional science-based HPC community. So I think I wouldn't call that a concern, Rich, as much as something we need to proactively sort of manage, which is this more productized, containerized virtualization where we're bringing in, let's talk heterogeneity now in terms of multiple machines running together in a coordinated fashion for a larger workflow, which makes sense, say, for machine learning based augmented workflows relative to science based. So now instead of a particular node being tuned for a particular aspect of the workflow, it's one system that's sitting in one state and another system sitting in another state. And we're working together in a much more federated, kind of cohesive fashion. So those are challenges moving ahead. And I think the containerization aspect is one key technology that's going to be enabling there. But let me make a comment about the time where we're living in. I do think that we're seeing with this pandemic the merits and efficacy and importance of computational biology. I think my own personal view is the science community and the HPC community, really has stepped up to the plate and shown that, what we're doing really is substantial for the quality of our life and society in general. And so, just ECP, we have very talented staff and we're doing everything we can to help knock out this pandemic and be ready to prevent or at least mitigate the next one if it does that comes along.
Well, terrific, Doug. Well, hey, I want to really thank you once again for your time today, and hope to see you soon in person at the HPC User Forum.
You too, Rich. It's good to see you in your red hat. I miss you seeing in person, and hope we connect real soon.